Okay, in this first video, I want to do the pH worksheet. One thing that you need to kind of know before we get started, anytime you see this concentration of H3O+, the brackets mean concentration, it's going to be the same thing as the concentration of H+. So those two values represent the same thing. And we get that from, if we write this reaction with HCl, we know that it's going to produce a hydrogen ion and a chlorine ion. Well, hydrochloric acid, or HCl, can only exist in water. So if we rewrite the equation of HCl plus water, we get H3O plus and Cl minus. So if you notice, we've got the same thing going on in the same equation. So H plus and H3O plus represent the same thing. And anytime we see H plus and H3O plus, you should automatically think acids. All right. So the first four questions, you can kind of look those up. Those come straight forward from your book and your notes. And you can kind of figure out those on your own. Starting with the chart, I have put down values in each box. Those values match up with the equations on the right-hand side of your screen. So these numbers in red represent the equation that you should use in each one of those boxes. So those will be the numbers that don't match up with the one on your worksheet. So for the very first row, we're going across on all of these problems. They give us the value for the concentration of OH. From that value, we have to be able to answer everything else in that row. So really, all we have is the concentration of OH. If we look at our equations, we have equation number 2, number 3, number 5, and number 6. So we should be able to get all our information from those. So I'm just going to start with the very first box. It has concentration of H3O+. So we're going to have to be able to get that value from the concentration of OH minus. So if we look through all of those equations, there's only one equation that contains both the H plus and the OH, and that is equation number 6. So this comes from chapter 15, section 1. Kw is our equilibrium constant for water. The value for Kw is 1 times 10 to the negative 14. And it's always going to be equal to the concentration of our acid times the concentration of our base. So for this very first problem, I'm going to start out with 1 times 10 to the negative 14 is equal to, we don't know what our H plus is, that's what we're going to have to solve for, times the concentration of OH, which is 1 times 10 to the negative 5th. So plug this in your calculator. 1 times 10 to the negative 14th divided by 1 times 10 to the negative 5th. And you should get that your H plus value is equal to 1 times 10 to the negative 9th. And so that's what you're going to put in that first box. So now we can go on to the next one. So for pH, if we look, we have number 1 and number 3 contain pH. On number 3, we have to have the pH and the pOH. And we don't have that yet. So we're going to use equation number 1. So pH is equal to the negative log of our H plus value. It doesn't matter if you know what a logarithm is or not. As long as you can find the button on your calculator, that's all we're looking for. So pH is equal to negative log and the concentration of H plus. Well, we just figured that out, and it was 1 times 10 to the negative 9. So now you should be able to plug it into your calculator just like that, hit the negative button, the log button, 1 times 10 to the negative 9th, and your pH value should be 9. Okay, so now, if something has a pH of 9, we can determine if it's an acid or a base. So you could go on and write that in the very last column. And then we have to calculate pOH. For pOH, we can use equation number 2. We can take the negative log of our OH value, which is 1 times 10 to the negative 5th. Or even easier, we can use equation number 3, pH plus pOH is equal to 14. So our pH is 9. We don't know what our pOH is, but we know that it's equal to 14. Let me rewrite that. Right. So when we solve for that, our pOH value is equal to 5. Right, so from that information, you should be able to answer all of the first row. So that's really it. Just take the equations that I give you and plug in the numbers that you're given and solve for your unknown. On the next set, move this out of the way. All right, so for number 5, what would the pH of each of the following? So on letter A, they give us the concentration of an acid. Well, I told you a minute ago, anytime you see H plus or H3O plus, think acid. So this value, this 0.0010 moles, is our HCl value. HCl is a strong acid. So that means all of our molecules of HCl are going to break down into H plus and Cl minus. So that means eventually I'm going to have 0 moles of HCl, and I'm going to end up with 0.001 molar of H plus. The board is just terrible today. So now this value is going to be our H plus value. So if we're looking for the pH of a strong acid, we can do the negative log of its concentration. So go back to equation number 1. Our pH is equal to negative log of 0.001. And we plug that into our calculator, and you should get 3. And that should make sense because it's hydrochloric acid. It should have a pH value of less than 7. So this only works on a strong acid and a strong base. So you're going to have to go through each one of these on A through J and determine, is it a strong acid or a strong base? And if it is, you can plug in its molarity value for its H plus or its OH minus. Speaking of that, look at C. C, sodium hydroxide. That is a strong base. So when we take the negative log of 0.01, we're taking the negative log of its OH value, not its H plus value. So we're no longer solving for H plus. We're no longer solving for pH. We're solving for pOH. So on letter C, if we take the negative log of 0.10, you should get 2. That's not our pH value. This is our pOH. So to get our pH value from that, we have to look at equation number 3. So pH plus our pOH, which is 2, is equal to 14. So if we subtract that now, our pH should be 12. And this should make sense because NaOH is a strong base. It should have a pH somewhere between 7 and 12, and since it's a strong base, it should be pretty close to 14. So 12 is a good value to represent pH for letter C. So make sure on the ones that are a base that you actually calculate its pH and not its pOH.